Hello, welcome to another lesson. So today we'll be talking about Cyberdyne systems. So this is an in-class exercise dedicated to risk aversion. So as Professor Hatfield talked about, risk aversion is essentially involving anything that managers use to avert risk. And while that may sound obvious, most of the word comes into play when it comes to calculating the utilities, the payoffs, and certain values of certain decisions. So in this case, we're going to be looking at Cyberdyne systems. So essentially, we have to decide how much of a bonus should we pay Mr. Dyson, who is in this case risk averse? How much should we pay him so that the chances of a new technology being successfully developed due to his efforts increases or is at its max? And the equation that we need in terms of X, which is his total compensation, is given here. So here we have the question, seizing the opportunity. We currently pay Mr. Dyson a wage of $1 million, but we feel like paying a bonus is successfully developing the technology will be worthwhile. So we should pay him a bonus of B if the technological development is successful. And we see he receives his wage of $1 million regardless. So the trick here, or not really a trick, the strategy here is to kind of build something and work backwards, as Miss Professor says. So let's go ahead and draw out a decision tree. So step one, draw not the decision tree, the game tree. Now you might be wondering, or you may not be wondering, why are we not drawing a decision tree? Well, here it's pretty straightforward. We pay Mr. Dyson B and something happens to P. So in this case, we'll go ahead and draw the tree here. So the reason why I've drawn it like this is, like I've said, first, let me try orange. So first we're going to try to give him a B, a bonus, and then that will obviously affect the probability, and that is what we're trying to maximize. So as always, we work backwards. We work backwards. So first we're going to optimize P, then we'll take whatever value of P we have and insert it here, and we find the B, the bonus. So what is the equation that we'll be using? So the equation, so step two, this is our favorite part, optimize. So in this case, I would recommend using Wolfram Alpha unless you really know how to use derivatives. I will do this in two ways. So one way I will go ahead and use X, and one way I will use 1 plus B. The reason why I'm doing that is because you can solve it both ways. As long as you're being careful, the B also works. So 1 plus B, in this case, let me go ahead and actually write that down here. So X is equal to 1 plus B, or you can use either or. So in this case, for the sake of this video, I'll go ahead and use X. So we're going to go ahead and use the same equation that we got from over here. So this equation right here, we're going to go ahead and copy it down here. So negative 1 over x minus p squared over 2. So here we have two variables. We have P, which is the probability of this being a huge success, and we have X, which in this case represents 1 plus B. We're going to leave it as such. Now the question is, how do we build this? So how do we build this out using this equation? Well, in this case, there are two possibilities. There is one probability that this is going to be successful. So in this case, P, if this is successful, this outcome, this is the final outcome. And if P is not successful, so 1 minus P, the remaining probability, we will get the exact same equation over 1. Now this right here is going to be 1 because regardless, he will receive his wage of $1 million, even if it's not successful. So this entire equation, we're going to now take the derivative in regards to P, because we're doing P first. So you plug this into Wolfram Alpha, and you will get, eventually, that P is equal to 1 minus 1 over x. And because you can do the same thing with B, you can also do P is equal to B over B plus 1. This is if you used B plus 1 instead of x right here, and then this is if you used x right here. So we have now solved for this equation. So we're going to go ahead and advance with this one first. Step 3. Let me do this in blue. Step 3, solve for P. So what's going to happen is that you go ahead and you plug this in. So P times 15 minus x plus 1 minus P times negative 1. Now, if you're wondering what is this equation exactly? This is our profit. So this is the point of view from us. So you have one probability that you get 15, right, minus x. So x is whatever we pay Mr. Dyson. Then we have 1 minus P times negative 1. And in this case, the negative 1 represents the 1 million we pay for Mr. Dyson, and no $15 million for us. So we solve this in terms of x. Now we're going to figure out from here what is the x value that we shall be doing it in. So we're going to go ahead d over dx. This will then show us that 16 over x squared minus 1 equals 0. 16 equals x squared. X is equal to 4. So the reason why we went ahead and did it according to x is because, and you're wondering why we're not doing it according to b, is because b is already covered in x. And for the sake of making it simple, we keep x. And you may be wondering, well, what happens to b? Well, because we've solved for x here, and we know that x is equal to b plus 1, we can simply do 4 is equal to b plus 1, b is equal to 3. So now we have figured out the bonus. So the bonus that we'll offer Mr. Dyson is I'm assuming $3 million. What is the probability of the successful development? Well, if we take, let's say, this right here, we go ahead and if we plug it in, P is equal to 3 over 3 plus 1. P is equal to 3 over 4, or 75%. We get the successful development will be 75%. What are our expected profits? Well, our expected profits are going to be, again, plugging it in here. So let's just go ahead and plug x over 4. Take this all the way here. We know the probability. 3 over 4, 15 minus 4, plus 1 over 4, negative 1. Expected profits will be 3 over 4 times 11 minus 1/4. This is equal to 33 minus 1/4, which is 32 over 4, which is 8. So obviously you can skip this longer division, but I just did this to showcase this. And our expected profits is $8 million. So that, in a nutshell, is how you do this example. It will only be straightforward if you know the proper steps. So in this case, if you know that you have to draw a game tree, if you know the order and you know what you're trying to optimize, you can definitely do it. And It'll take a couple of tries, but I think that after getting the hang of how to solve these kind of problems, you should be able to do this without a hitch. So thank you again for listening and have a good rest of your day.